Okay, let's jump right into this explainer. Imagine we're throwing a massive, ultimate party for your entire computer science cohort. You've got all your friends coming over, right? And we need to figure out the absolute best way to arrange the room so that everyone can easily talk to each other without it turning into total chaos. So you'll hear the term network topology thrown around a lot. But honestly, it's really just a fancy technical way of describing our party's floor plan. It dictates exactly how our guests, which, in networking terms we call nodes or devices, are physically or logically connected to each other across the room. It's basically the architectural blueprint for how our data packets are going to mingle. Here's our party planning checklist for today. We're going to cover the 5 essential setups you absolutely need to master for your syllabus: the long table, passing the mic, the center stage, direct connections, and finally, the ultimate bash.
All right, Section 1, the long table, also known as the bus topology. Picture seating literally all of your guests along one incredibly long communal dining table. That table acts as a single main pathway, or a backbone cable, connecting everyone. Now, on the plus side, a bus topology is super cheap and it's incredibly easy to set up, but the trade-off is pretty huge. If everyone tries to shout across the table at once, you get massive data collisions that just eat up your bandwidth. And even worse, if that main backbone breaks, the entire party is over. The whole network goes down.
Which brings us to a big question. What actually happens if that main table snaps right in half? I mean, a single point of failure like that is a really big deal in systems design. If the thought of one broken table ruining your whole event makes you sweat, you're probably wondering right now how we can arrange this room differently to make sure the conversations keep flowing. That leads us directly to number 2 on our list, passing the mic, or the ring topology.
So instead of that long, straight table, let's rearrange our guests into a continuous, perfect circle. And to completely avoid the chaos of everybody yelling at once, we're going to add a new rule. We're introducing a digital talking stick, which is known in networking as a token. So guest A gets the token, sends their data, and then passes it to guest B, who passes it to guest C, just moving step by step around the ring.
Now, this setup is great because it totally solves our collision problem. It gives everyone completely fair access to speak, but imagine trying to pass that single token around a circle of 1,000 guests. Yeah, the latency can be painfully slow for a really big party. Plus, if just one person decides to leave and breaks that physical circle, the token literally can't get past them. And boom, once again, the whole network fails.
Let's move on to Section 3 to fix that fragility, the center stage, or the star topology.
To solve the vulnerability of the circle, we introduce one of the most common setups out there. Think of this as having all your nodes sitting around one incredibly attentive central host, like a network switch or a hub. The guests don't actually talk directly to each other anymore. Instead, they whisper their message to the host, who listens, figures out exactly who the packet is for, and then relays it directly to that intended person.
The massive advantage here is that it's super easy to add new guests without disrupting anyone else. Like, if one guest spills their drink and has to leave, only their specific connection to the host is severed. The rest of the party just keeps going. But there's always a catch, right? That central hub is now your massive single point of failure. If the central switch gets overwhelmed by too many packets or just loses power entirely, all communication instantly stops dead in its tracks.
Okay, number 4, direct connections, better known as the mesh topology.
Let's say your party is highly sensitive and you absolutely cannot risk that central host failing. Well, you'd give every single guest a direct, private tin can phone connected straight to every other guest in the room. Now, mathematically, to figure out exactly how many direct physical cables you need for this, you use the formula n times n minus 1 divided by 2. To put that into perspective, a tiny network of just 10 nodes requires 45 separate cable connections crisscrossing the room. And that right there is exactly why a full mesh topology is rarely used for your standard local area networks. I mean, sure, the reliability is completely unparalleled. If one string breaks, you've got a dozen other routes to get your data packets across. It is perfect communication. But the sheer volume of cabling, the physical space you'd need, and the astronomical cost quickly turn into an absolute nightmare to manage as your guest list grows.
Finally, number 5, the ultimate bash, or the hybrid topology. So a single long table is too chaotic, the circle is too fragile, the host gets overwhelmed, and the direct strings are just a messy nightmare. What do network engineers actually do in the real world? They mix and match. Imagine a sprawling mansion party. You might have several small, distinct rooms where nodes are arranged in a star configuration, all talking to a local host. Then, to connect all those separate rooms together, you link the hosts using a high-bandwidth, central bus-style hallway.
This hybrid approach is exactly how massive corporate networks, university campuses, and the global internet itself actually operate. By combining setups, you get the pros of multiple topologies, giving you ultimate scalability and flexibility. But of course, you're inherently trading away simplicity. Designing, securing, and troubleshooting a network that relies on all these multiple overlapping topologies is a highly complex engineering challenge.
As we wrap up this explainer, I really want you to keep this golden rule in mind. There is absolutely no single perfect network layout in computer science. There's just the right tool and the right topology for the specific scale and constraints of your problem. It's all about balancing latency, bandwidth, and your budget.
So now that you know exactly how the guests can communicate, whether they're sharing a backbone table, passing a token around, whispering to a switch, untangling a giant mesh of strings, or mingling in a massive hybrid mansion, the choice is totally in your hands. Which party setup will you choose to engineer for your very first real-world network design?